putting it all together, what do we know about a system of equations? We know that a system of equations is two equations. When we solve them, that means that there would be two lines on the graph. If we get an answer, x equals and y equals, this answer represents the point of intersection for the two lines on that graph. So there might be a visual of the graph, line number 1, line number 2, and our answer is that point of intersection. What is the x-coordinate? What is the y-coordinate? If there is no solution as you're solving, meaning as you solve, you get numbers that don't make sense, the x's canceled out and the y's canceled out, but you're just left with a number, 6 equals 0 or something like that, that means that there is no solution when you're solving. These two lines are parallel. They are never going to intersect. And the last situation is infinite solutions. If we're solving our equation and the x's cancel out and the y's cancel out and only thing left is zeros, we have like a 0 equals 0, there's nothing there. It's because everything was the same. The two lines are exactly the same. So we have line 1 is the exact same as line 2. And since they are intersecting at all points along this line, we would say that this has infinite solutions or infinite points of intersection that are all intersecting along the line. Now that we know what our solutions look like in terms of a graph and what we could have as possible answers, we need to look at what strategy should I use to solve a problem. We've learned 3 strategies so far. Equal values method, when both equations are in y equals form or x equals form. Substitution, when only one of the equations is in x equals or y equals form, and we can replace that into the other equation. And the last method is elimination, when both equations have the x's and y's lined up on the left and they equal a number. And we can try to add the two equations together to have the x's or y's eliminate from the problem. So I'll do 2 problems with you and you'll do the rest. Notice the setup for part A. I have this equation that says x equals. If I was to solve that, I would take what x equals and substitute it in for the other x. This is the substitution method. For now, just identify the method and don't finish solving them. In problem B, we see that both equations have the x and y lined up, where if we tried to add them together, we would be using that elimination strategy. However, the x's and the y's don't cancel out yet. We would need to multiply one of our equations with a negative, change all the symbols to negative in order to have the y's have a positive y and a negative y that eliminates. But this strategy is called elimination. You need to continue picking a strategy for each of the remaining 6 problems, elimination, substitution, or equal values. And then there are a few for you to practice solving for x and for y.